So welcome back to another episode of Science Exposed. I'm Patty.
I'm Tracey.
And we're from Praxis. This week, we are going to do slime. We get so many requests and so many kids come up to us and tell us about their slime. So these are some tested and true proven slime recipes.
So, you're the slime queen.
Well, we'll see by the end of today. So Webster's Dictionary defines slime as anything mud, gooey, ooey, viscous, filthy, disgusting. We might be doing some or all of those things today. You might ask, what does viscous mean? So viscosity actually means the resistance to flow. So some things flow better, some things flow less.
If it gets colder, it becomes more viscous?
Exactly. So you've heard, that saying like, as cold as molasses in January.
Hey.
So yes. So when you heat something up, it gets low viscosity. And when you cool something, it becomes more viscous.
High viscosity.
So we're going to see that today and how the slime flows. And sometimes you want it to flow more than other times. So it's going to be exciting to figure that out today. The first slime we're going to do is, I call it the world's best slime. It usually works without fail, okay. But we'll see if that's true today. So we both need... I'm just using cups today because just to save on time and washing. You could do it in bowls. You could do it in whatever you want. I recommend you don't wash any of this down the sink, preferably, because the things we're using could clog your drains and the sewer system in the city. And these can easily be disposed of in the waste. And I like the clear ones because you can see what's going on in here.
One for me, one for you.
So one for you. I like to stir with just a popsicle stick or a skewer, so you get one. Oh. But do you know what?
I do.
Oh, what should we do first?
Safety first.
Safety first. Let's put our goggles on.
I was waiting for it.
So there we go. We'll put our fancy goggles on. So the first thing we need to do with the world's best slime here is we need to make a solution. A lot of the chemicals you use in slime, I'm going to say chemicals in quotes because they're things that you're going to find around the house everywhere. So for instance, this chemical we're using is borax. A lot of people use it in laundry. It's sodium tetraborate is the chemical name. Wash your hands when you're done with it. Don't smell it. Don't stick just like any science experiment. We want to be safe. You're not going to stick your nose in the box and start whiffing and smelling it, right?
Use your head.
Yeah, common sense. And don't eat it, I guess. But that's a rule we have with science all the time. All your experiments. You should not eat or drink anything that we're working with here, right? And something else that I want to be really important with when we're doing, especially experiments where things are clear and might look like water, we should probably label what we're using, especially when we're using simple cups. People might walk by and take a drink of it. So
is that why you got this? That's
why I have just a Sharpie marker. I'm going to use this beaker here and just some tape so we know what we're doing. So you just pull off a little tape. Just so you can remove it later. It's not a big deal. We'll put it on here.
So what am I actually labeling this?
Borax solution. Okay. So anyone that looks at that should know.
Okay.
Now, we need to measure 1 cup of just plain water is fine. 1 cup is 250 milliliters, perfect. And that is, you can see 250 milliliters is up to the top here. Okay. So we'll just measure that out. Now, when we're measuring liquids, should we stand over top and measure? How do we measure liquids? Do you remember?
Oh, yeah. You have to look at the
meniscus. So you want to get down there and look. We're pretty close to the 250 mils.
Is this pretty exact a recipe that you're using?
In science, we should be as close as possible, okay. Like cooking, because small measurements could throw it off. So I'm going to say we should try to be close.
They look pretty good too.
So we have 1 cup of water there. And I have measuring spoons. Some people might use scales, but that's hard for people to find. So you have measuring cups probably at home in the kitchen and measuring spoons. We need 1 teaspoon of borax. So I'm just going to get my 1 teaspoon.
Leveled?
Yes, or 5 milliliters. Now, an interesting fact, do you know why borax is called 20-team mule borax?
I actually didn't know it was called that.
It is. If you look at all of them, that's the name of it, mule 20-team.
Okay.
Because way back like in the 1800s, when borax was discovered in Death Valley, 20 mules actually hauled it out of the mine. And the name stuck.
So this comes from Death Valley.
Yes, it comes from Death Valley. So stick it in and just give it a stir with your spoon here, or your stick, sorry.
So it kind of until it dissolves?
Yes, you want it to dissolve, exactly.
Okay, what's next?
Now we're going to use just a basic white glue. This may look odd. You probably just buy school glue in the little containers. That is just fine. Exactly. We use a lot of glue, so we buy it
In bulk.
the larger containers like this. So we want about we want 1/4 cup of glue.
Okay, and I think I'm dissolved here.
Perfect. So just set that aside for a minute. So 1/4 cup of glue, which is 125 milliliters. So we'll just use this.
I'll hold that for you so it doesn't tip over.
Thank you. And it's, again, this might not be very viscous.
It's appearing to be very viscous. So
Oh, now there it comes. Okay. So 125 is to the top here.
closer.
Sorry, it takes a little time here. So there you go. Pour that in your cup. Go ahead and pour it in. Your clear cup, yeah.
This isn't going to come out very well.
It's slow.
Okay, well, we'll let it sit here for a bit.
So I'm going to mix mine in here.
Okay.
Speed things along a little bit.
I am going to, yeah, this is really thick glue.
But don't worry if you can't get the glue out, because we're going to add water next, and it'll bring the glue out. So
Okay. Into this
into the graduated cylinder.
graduated cylinder. Okay, I was going to call it a science thing.
Well, that's fair. So there's 125.
I'm going to definitely need to put the water in
Yeah,
here.
no,
Okay.
that's okay. So we'll just use set that aside. Give you some water.
How much
again.
water do I get?
Exactly the same amount.
Oh, okay, so right up. There we go.
There we go. And you might want to just give it a little swoosh.
Swoosh, swoosh, swoosh.
There.
Do you need yours in yours too?
I'll get some as soon as you're done.
Okay.
Yes.
Go, incoming.
Perfect. Now I want you to stir that really well. You want to make a solution with the glue and the water.
Okay. Let's get a little bit more glue. I think there's still some left in there. There we go.
Perfect.
Okay. And so a nice, like, again, dissolved.
You want it mixed perfectly. And I need a stick to stir with as well.
Pretty good.
Oh, yours is coming along there. Yes, yes.
Yours looks better.
I think just because you can see better in the bigger vessel.
Okay. Okay.
So we actually need, this is liquid. You can see how it flows, right?
Yeah, that's one of the qualities of a liquid,
It's
sure.
not very good slime.
Well, I don't think it's gonna.
We need to make this thicker.
Okay.
So with that being said, we're going to add a few drops, 5 milliliters at a time. I have these nice pipettes, which are 5 milliliter measures, just with your borax solution. So you're going to add it.
How
and
many
then
did you say?
5 milliliters at a time, and stir it up. And you're going to see things start to happen. You're going to feel it get thicker.
Yeah.
And you kind of just play it by feel and how thick you want it. I personally like, 3 or 4. I like a little thicker.
Okay.
I'll give you
Yep.
another one.
Beautiful. This is the borax solution that we're putting in there that we just made, right? Yeah.
Yes. So again, not real thick yet.
No.
I'm going to add 2 to mine at once here.
Well, you've
'Cause
got
I
to.
know I want it thicker.
I'm going to go ahead and try that. You getting a reaction?
Oh, not yet.
Oh.
How about you? Can you feel it clumping?
Well, I think that part of my issue is that I honestly didn't have as much glue. There's still a fair bit stuck in the graduated cylinder. However, I'm hopeful that this is going to work.
Well, it's the world's best slime. It's supposed to work.
How you doing?
Good, good. Well, do you know what? I'm a bit worried
That I didn't dissolve?
that some of our borax might not
Well,
have dissolved.
I noticed that our water's been sitting there for a while, and it's not really warm, and I know that things dissolve better in warm water.
It might have cooled off a little bit, do you think?
Possibly. So this isn't, like, this part here is just a kind of winging it, right? Like, we're not...
There's no, like I said, it depends on how thick you want it. Usually after 4 or 5, it works really well. But I'm not quite having that luck today.
Might have to just start dumping the borax solution in there.
Well, I hate to go too far.
Well, because then you do get the clump of slime. You don't really get the stretch that we're after.
Exactly. You're going to go for it? Well, good thing I made some yesterday. Well, do you know what we can do now? Actually, it's not very thick yet. You can make glow-in-the-dark slime out of this.
Oh.
And what you would do before it actually starts to get thicker is you could just get this inexpensive glow-in-the-dark paint at any craft or hobby shop. And you
Nice.
just add it in here.
It's just like a tempera paint, actually.
Yeah, yeah, and you just stir it in. You stir it in and it'll glow in the dark. It really does. Or you can get zinc sulfide. It's a special powder that glows in the dark. It's a bit expensive, but you can buy this online.
Oh, yeah.
But this works phenomenal. But this is what you get here.
Okay.
So it works, trust me. I don't know why it didn't work today. So you get a nice ooey, gooey, oozing slime that glows in the dark.
That is like super oozing.
Well, it's not all going to mix. You're going to have that little bit of liquid left over, so you want to work it in. And this will easily, it glows in the dark. It's pretty cool. So it'd be nice for, those holidays during the year where you want something to glow in the dark and be kind of ooey and oozing and gooey.
Cool.
So it's very nice.
Well, you said we were going to do more than one slime anyways, so
Yes.
what's your next one?
Well, I think we should do a nice quicksand slime. So can we...
Oh, that's
Let's
awesome.
just move this out of the way here.
I'm still playing, I got to admit.
So we'll just I'm going to scooch behind you here, and we'll grab the quicksand slime.
This one, I think I know what you're going to do here. I like this one a lot.
So I like to get a nice big vessel to work here. And we're going to get in there with our hands. This one is a messy experiment. And,
The idea of slime kind of...
well, if you're going to do slime, I guess we're going to get dirty. Like, let's do it. So you're going to use a whole box of cornstarch.
Oh,
Very simple. Get it at the grocery store, cornstarch. Open it up. It's dusty, and it makes a mess, so you might not want to do this one inside. And you're going to pour it
okay.
into your container. You could use a bowl. I like these big containers, and I'll explain why in a minute here once we get it all mixed up.
Sounds really,
It's quite messy, yes. So to the cornstarch, we want to add a cup of water. So we'll use this.
okay. Where's the cup up to?
Well, a cup is 250 milliliters. So right there.
Okay.
So we'll just set it there. Now again, this you might have to add a little more water. We're going to start with 1 cup
You nailed it.
of water. We might have to add a little more. So let's add it in and start mixing with your hands. Yes. If you want, at this stage, you could also add food coloring. I don't necessarily, this isn't one of my favorite activities to add food coloring to. We're going to get there yet and color some slime.
So I'm going to...
Get in there with your hands.
Oh, it doesn't feel like how I expected it at all. I think I need to roll my sleeves up though.
Oh, that might be a good idea.
Okay.
I suspect we're going to need about another
I think
quarter.
I need to show people what's happening here. It's like kind of clumping.
It's going to clump. And it's, you know, you were onto something. As you're mixing it, squeeze it. What happens when you squeeze it?
Well, it's liquid, but it's becoming, it's clumping.
It becomes a solid, but as you squeeze it, it becomes a liquid. This is known as a non-Newtonian substance. It doesn't really adhere to the laws that Newton put forth with liquids, liquids that like water that flow. So it's the pressure. The pressure makes, you can see it, the pressure, and it just oozes out.
I think I need more liquid.
What I like to do with some children is they put their farm animals in here and they make it act like quicksand.
They put their
Little farm animals or
like
little
we're talking
trucks and
toys here.
Yeah.
Okay.
Yeah. Not the real ones. Don't get me wrong. And then it acts like quicksand, so you can really learn how. If you're in quicksand, should you flail around madly and try to get out? Like, is that going to work for you, or should you lay flat on your back and create as much surface area as possible?
What should we do, or what would I do?
Well, exactly. But you can, it's really, squeeze it and you can see it, the clumps.
Oh, yeah.
So this is a really fun one.
I could see my kids getting right into this.
Mm-hmm. And young children really like this sensory play, right?
Oh, good one.
They can just get in there. That's what science is for young children. Experience it, get dirty. Don't be afraid of the mess. If you're afraid of this, do it outside or lay down, some plastic and just let them get in there and discover it.
Man, I'd fill up a swimming pool.
Well, you could buy a big bag of cornstarch, I suppose. Probably sell it at a bulk warehouse of some sort.
Okay.
So this one's quite cool.
I'm getting both hands in there. This is it. Look at that. So I pick up the solid, and so it's a solid in my hand, and then when I squeeze it, if I can get it off,
the pressure makes it a liquid.
it's really neat.
Goes against all the rules of, usually temperature affects how it flows, right?
Cornstarch, defying the laws of, what is that?
Of science, yeah.
Okay, I could play this for a long time.
I know.
How much time do we have?
Do you know what? I'm going to give you mine because we're actually going to make a similar substance like this, but we're going to make it so it is attracted to static electricity. So,
Cool.
it's the same idea. I just need to get the measurements out here. We're going to just use, and it dry. It's funny how, look, your hand feels dry already, right? But it's still quite dirty.
Okay.
But it doesn't transfer. So we're going to use.
I'm just gonna sit here and play this with this while you.
May I have the beaker beside you? We need.
I'll get you. To,
Oh, here. Excuse me. I'll just reach across there. So we need just a quarter cup of cornstarch. So a quarter cup. Divide 250 by 4. We got about 60 mils. Again, this one we're gonna kind of play with. Looks good. I'm gonna do it over here because it gets a little bit messy. Now we need to add half a cup of oil to that.
Get some oil there. Okay. Now it's okay that you're putting it in that container that you've already used.
I already had cornstarch in here, so
Yeah.
I'm not too worried. So half a cup of oil.
I can't wait to see this one. Oh.
This one's ooey gooey. Before I get in there with my hands, I'm going to do something that we can create the static electricity with. How do you think we could create static electricity quite easily? Just standing here.
Do you have a balloon?
A balloon!
Oh, we'll get out. I was right.
Yes, we're going to blow up a balloon and we're going to use
See
that.
those there.
So, like I said, this is going to get messy, so. Oh, someone's going to get dirty, though. Maybe.
Why do I sense it's me?
Who wants to rub this in their hair? I might not have tied that.
I would offer to do that for you, but this is so weird.
I think I got cornstarch all over my face. This is a messy day. Okay, here we're just gonna.
Yep, go for it.
We got we got good static.
Okay.
So I'm gonna just hold this in my hand here while I mix this up.
Okay.
It's not quite as nice as the water because it gets all ooey and gooey and
Oily.
greasy. Yeah, this one's a bit. Now I have to set this down for a minute.
I think it's gonna stick to.
Is it gonna stick to me?
I would totally help you, but I'm kind of. I feel like this feels. It does. It feels dry, even though my hands are clearly
clearly wet.
wet.
So it's really hard to mix the cornstarch. It's not cooperating here.
Is that the whole?
Well, we want it a little thicker here, so
More.
I'm gonna have to add a little more cornstarch. Science clearly is not our friend today.
Oh, I think this is pretty good. How thick is it going to be?
Well, you want it to be able to pour, right?
Okay.
Before it was and not pour like super fast.
Okay.
And as we hold the balloon close to it, you're going to see that it's going to be drawn to the electrical charge.
Okay, I can't wait to see this.
We
You
have
got
better,
it?
Better, much nicer. So, do you want to hold the balloon?
Sure. Is it okay if I get stuff on
But
it?
let's maybe just charge it up one more time here. It's a little. Oh, I love this. That's a good part of my job. See how staticky that is? Oh, that's lovely. Maybe hold it by the end so we don't discharge.
Oh.
And you want to get quite close as I pour this.
So we're good for the static?
Yeah.
Okay.
Now I'm gonna hold your balloon right about here, and it should be drawn to it as I pour it. See? Can you see that?
Yeah.
I'm not pouring it towards the balloon. It's actually going towards the charge. You can see where it was sitting just on top there.
I think I just I let it touch, so I think we're going to. I've lost the charge here.
So
that was really neat.
That's pretty cool, right? So
Is that the? That's the cornstarch that's doing that.
the cornstarch in the oil, yeah.
Is it okay if I try it?
Yeah, oh, for sure, for sure.
Oh, yeah, it's totally like.
Yeah, the cornstarch becomes polarized, so it has that electrical charge to the balloon. Very nice. Very nice.
Yeah, that was really neat. Well done.
Good, good. So that was...
You weren't lying about the mess, though.
It's messy, but hey, tons of fun.
Is there a secret to discharging? Or am I like this now for...
Static guard.
Yeah, static guard. Okay.
Awesome. So, on to the next
yeah, what do you got? What else you got?
This is just a microwavable slime. So you need access to a microwave. Okay. And this is a fiber powder. Do you know what? This is another interesting fact. Someone who was in space, they were allowed to take one thing with them, and what do you think they chose to take?
They did not take that.
They took fiber powder in the form of a cracker to keep them regular while they were on their space mission.
Well, in space, I would imagine that would be very important.
So very, it is. So you can buy this at any drugstore. We buy it in the large containers because we might use a lot. And I see it regular. We use it a lot in science. And I always like to get the flavored kind. Perhaps it tastes better, I don't know, but it smells really nice. And the color.
They have the lemonade kind too, right?
Lemonade, that's my favorite. This one's orange, but the lemonade one actually smells quite nice.
Okay, let's check it out.
So this is probably one of the easiest ones that we're going to do. So you basically need 1 cup of water.
Okay.
How are we doing there? Right about there. And then, I still got cornstarch all over me.
I know.
And then we need to measure in some of this fiber powder. And we're going to use 1 teaspoon. Where did my teaspoon go? Or 5 mils. Well, let's use this one. It's clean here. This is half, so we'll have to use 2 of these.
Okay.
And it really doesn't look like much right now. You can see it's just this powder. It's brown, kind of granular.
Can I touch it?
Yeah, it contains some special things in there so it can absorb lots of water. It has psyllium husks in there, and that's what's really going to help us absorb all this water. So do you want to stir that up?
Sure will.
Please.
A bit of a chunk in there.
And yes, you have a good point. It does get kind of chunky, so you really have to stir it for a while. Now, what you do from here, for sake of time, we're not going to do it, but you would put it in the microwave for in 30-second intervals. Now, it's hard to tell you how long it might take because every microwave is different. So For every 30 seconds, use an oven mitt because this gets super hot.
Oven safe.
Yes, always has to be in an oven safe vessel as well. So a cup or a measuring cup or a bowl.
It smells really good.
It does smell quite delicious at this time of the day, right? And every 30 seconds, take it out, give it a stir. And you're going to do it for, it takes about 5 minutes and it is super, super hot. Now, this is where your patience comes in. You cannot play with it right away. You need to let it cool for 10 or 15 minutes because this is holding so much heat.
It would be boiling hot, yeah?
Boiling hot. But ours is cool. I made it earlier. And so you want to hold out your hands and feel.
Is it going to react with my cornstarch?
No, it's just cornstarch. But look at this, how well it. It's gooey, kind of
gelatinous.
And it's.
Here it comes.
And I should mention that most of this slime.
Oh, that's so gross.
Most of this slime will keep really well in the fridge in a Ziploc bag. And yeah, like it oozes this one. It is the best. We've created a colloidal suspension here.
Say that one again.
A colloidal suspension here. A little bit different. The liquid is dispersed in the solids. So a little bit different science than in the other experiments, but it is tons of fun. This is kind of like the slime you would pay a lot of money for in the toy store. And it costs like literally 1 teaspoon of this fiber powder. This would literally be months of fun, I think, if you bought one of these.
This is fantastic.
And it couldn't be easier to make. Like I said, mix it together, put it in the microwave, and just keep stirring it till it's as thick as you want it to be. I know I've got it as thick as it was like little bouncy balls. And
oh, wow.
If you leave it out, it does harden into quite a hard ball. Don't get it in your carpet. It might be a little difficult to get out if you do that. But yeah, this is one of my favorite.
And even though these ingredients are technically food safe, we never want to eat our experiments.
No, no, even though it smells so good, right? It smells like oranges right now. And
so is this a liquid? Is this classed as a liquid?
It's slime. It's
slime. But
it's a mixture.
It's like pouring. I don't know. It's so cool. Okay. I better put it back.
So that one is pretty awesome too.
That one's my new favorite, yeah.
So this one I like to call snot slime.
That last one was kind of snotty, so I can't wait to see what you got.
But this one we're going to make nice and green. Hey, did you know another interesting fact?
You're full of facts.
I have lots of facts today. The average human produces 1 liter of snot each day. And you know what? It should not be green or yellow. That means something's wrong. You probably have an infection.
1 liter.
1 liter. I know. I could not believe it either, but I was reading it.
You're not saying that we're blowing our nose.
No, but it drains, and you know it's part of the human body and how it works.
Fantastic.
So it shouldn't be green, but we're going to make ours green today.
Disgusting.
Now this one, I kind of eyeball the recipe because I've done it, and I shouldn't say this, but it works. This one works every time. So
famous last words.
I know.
What have you got here?
Well, this is a liquid starch. Now, this is not that easy to buy in Canada. If you travel to the United States, it's very accessible in the laundry section there. You can also buy it online through Amazon or any sort of online retailer. It really is essential to this slime, and it makes one of the best slimes I think that you can do. So I pour equal amounts of starch and glue into a container.
Should I go ahead and
you could do that, yes.
You got the clear glue here? Is that?
Yes, and that's a good point. I really like the clear glue for this experiment because it makes it look more like snot, right? Whereas the white glue is more, it's not as opaque, so yeah.
I'm getting down here. I'm going to see what this is about. Oh.
And I'm going to add a couple drops. I want green.
Absolutely. I've got like a...
Do you want a couple green drops in there?
Sure. Will it mix into the glue?
It should, just fine. So I'll trade you. You take this one.
What am I doing with that?
You're gonna.
Oh, we're making each our own. I thought we were gonna
make
those.
our own. Oh no.
We're doing this.
Oh, I see what you're doing. Equal amount. I got you.
Yeah. Okay. This is tricky. What do you think? One more little blob. Okay.
Oh.
Is this it?
This is it. Look at that. And like I said, it's almost instant. You get this nice booger-like consistency.
It is a booger. Oh, that's fantastic.
And you can take it out just for sake, because I don't want to clean up my hands anymore. You take this out, and this is amazing stuff. Some kids that I've done this with, some students, like to mix glitter in here, and they call it unicorn slime.
Unicorn snot.
So I have glitter here. You can do it. Amazing how quickly that reaction is,
That's
right?
good. Oh my goodness, that's fantastic. Is there a little bit of like it's kind of forming in the center? Hey.
Well, I think it's because it's grabbing on, it has something to grab onto there.
Yeah, sure. I'm gonna put some purple in with my green.
So you can see it feels it's very cold and oozy.
Oh, I love it with the sprinkles.
This one comes off your hands quite easily.
Quite nice. Okay, I'll try it then. I wasn't. Here it
Are
comes.
you going to take it out?
Oh yeah, I am.
Oh. And you can mix like a lot of sprinkles in there, and you see that stuff they sell in the stores now too.
Best booger ever. Oh, I got a hair in there.
Well, that's possible.
And this is just, I don't think I actually did my equal parts well, but it doesn't seem to matter because.
This one, like I said, it works so well. You know, you're getting, in the starch, there are chemicals in there that are like the borax ions that make that cross-linker and make it gel into the slime.
I'm trying to think of the words. Is catalyst the right word, or is it a polymer? I remember hearing those words when we're talking about slime. This one's got to be a polymer to make them stick together.
Yes.
Okay. Oh, fantastic.
Okay, so are we good with this one? Should we move on to the next?
I should probably put it down.
Okay. So this time we are going to make a magnetic slime. I'm sure you've seen this. Now this probably was one of the most frustrating slimes to make because you want a slime that is going to flow so the magnets and the iron filings in it will work really well. So it took me a lot of time to actually get this experiment to work well with the slime. Again, we're going to have to mix a borax solution, so we need to grab the borax again, right beside you.
Okay. Now, I noticed you've got gloves there. Why are you? Why do we have to wear gloves with this?
Oh yes,
slime
that's a good
experiment.
Point. Because we're gonna use iron filings, and they're very small, and they can get into your skin really well, like almost like metal slivers. So yeah, once we start mixing it by hand, we're going to use the gloves.
Okay, do I pour some water into my borax here?
You bet. It's ready to go. There's the borax.
Do you want that on the ground? Sorry.
Yes, we'll set it here.
Not on the ground, I meant on the table.
There we are.
And I'll just dissolve this. And then what's your next step?
The next thing I like to add 2.5 ounces, or I measured this one in ounces, not in not in metrics. So that conversion could fail me right now. 2.5 ounces. 4 ounces is half a cup. So 2 ounces would be 1/4 cup of white glue.
No, I agree with your conversion there. How am I doing? Oh, this is not.
So let's measure this. Is it not dissolving again?
Yeah, a little bit.
Oh dear.
Got a little bit left in the water. Or maybe I've.
Maybe we've had made a saturated solution here.
Yeah, that's the word I was looking for. That's okay though.
Again, it's not warm. The water is cooled off, so that could be affecting what we're doing.
What now?
We need a pipette. I have some pipettes right here.
You're good to go with this glue?
Yes.
Okay.
I need liquid starch again. Where did I?
I'll grab it.
The liquid starch.
It's with the snot.
Perfect.
There we go. Okay.
And I'm going to add the same amount again of that. And we're adding the extra borax this time to just because of, I said, remember the flow. I want this to flow a little bit differently. So we're tightening it up with a little bit of the borax. See, this is going to start gelling.
I can see, yeah.
But we want to tighten it.
Now what will that entail with this?
It's going to be, we're going to do a squirt at a time because we're going to have to feel it. We don't want it to go over or under, so go ahead and add a little bit.
Okay.
And you can see it's starting to tighten up really nice.
Okay.
But I don't think we're quite there yet, so maybe add one more.
Oh, my pipette's not cooperating. What do you think?
I'm going to start working the iron filings into this
Okay.
now. So, or do you want to? You want to put the gloves on?
Sure.
And I can sprinkle the iron in. And I think just for sake of mess, we're going to do it on the plate here. So there's going to be some liquid left in here, so try not to dump all that liquid out. We don't really necessarily need that. You can use the stick should you wish. Oh, here's another glove here.
Oh, sure.
And you can see how strong the iron filings are. My magnets are already attracted to the bottle.
So you've got really strong magnets there.
Yes, I was going to say you need to use a rare earth magnet. A normal magnet is not going to be very strong. Be careful with a rare earth magnet. They're so strong you can pinch your fingers in there. Not ideal for young children. You're going to see, I like how we have one big rare earth magnet, which works really well. But also these come in a stack like this. You can see the stack.
Those are really hard to separate.
They are, and you don't want to really leave them leave them together. I'm trying to take the washers off the end because we don't necessarily need those right now. So I'm gonna set them apart. Okay, you're working that really well.
Yeah, it's turning into a really nice slime.
And we're just gonna start sprinkling. Again, iron filings you can find in hardware stores, your egg supply stores. Ask, people look at you funny, but they're around. Or you can order them online.
Okay.
So we're just gonna, and you're gonna knead it kind of like dough. You're just gonna keep kneading those filings in until you have a really, really nice disbursement of those iron filings in your slime. I think, how's it going there?
I think it's pretty good. Gonna pick up some of the filings down there.
Do we need more, or how
Well, you tell me.
Well, we want it a little bit more. I see some, you want it to be fairly, fairly dispersed throughout.
Okay.
Mix it well.
Okay. This is a nice feeling slime. It's really stiffened up from when I first took it out of the glass.
So let's see how we're doing here.
Okay.
Now we should be able to, the slime should be attracted to our magnet. You should actually see it kind of jump, just like it did in the electrical, like with the static electricity one that we just did. So let's see how.
Okay. Oh, there we go.
There. So you got to stretch it out and thin it a little bit. Do you know one experiment, or one thing I like to do to show is I call it magic slime. It's going to swallow up this magnet.
Let's see it.
So you're just going to take your magnet and set it on top.
Come on. Do we need more? Oh, it's going down.
Can you see how it's actually sucking in? She's not doing anything. It sucks it right into it and just swallows up the magnet. Here, let's try these really strong magnets.
There it goes.
And now we have extra strength. You can see it's pulling itself right into the slime.
Yeah. It'll bury it.
Yeah. But don't worry, your magnets clean up just fine.
Is that right?
Yeah, it's amazing because it's so gelatinous and gooey that it just, cleans up very well.
This is a really nice one. Oh, no, you're right. It totally just came out.
Comes right out.
Oh, goodness gracious, sorry.
Very nice. Okay, should we move on to the next one?
Absolutely. I'm just going to hold on to this one maybe.
Move that one on. Oh, now this is a fun one. This one makes some nice ooey gooey worms.
Worms.
Worm slime is what it's called. So now this one calls for some ingredients that are a bit odd. You need calcium chloride.
That sounds dangerous.
Well, it might be. You can find it actually in household things. It's an ice melter. Quite often for your driveway, you might use it in the winter.
Okay.
Or a very interesting place you can find it is in the canning section in the grocery store, as sold as something called pickle crisp.
So maybe not so dangerous.
No, because we eat calcium chloride. Again, I wouldn't recommend eating this by the spoonful. We don't eat anything that we're using in the lab, but safe. And you're going to get something out of your medicine cabinet, some Gaviscon.
Metamucil, Gaviscon.
Well, I know, antacids are tons of fun. Again, you might want to supervise your kids when you're doing this just so you make sure that they're not going to eat or drink any of this. So basically we need to make a 1% solution of the calcium chloride. So you need 1 cup of water, up to the 2, right to the top
250,
there.
yep.
Good. Now you need 1 teaspoon. Where did the teaspoon go? Here, we'll use this one. 1 teaspoon of calcium chloride.
These are a little granular.
It's quite yeah, you can see it's
Okay.
just granules. So you want to be safe again. We should have labeled this. So you go ahead and mix it in. I'll get a piece of tape to label our
Drop it in and
give
stir
it a
it.
stir. Yes.
Okay.
So we're just going to put.
So I feel silly asking this, but am I using the right end?
You can use whatever end you want. It's not.
That dissolved really quick.
Yeah.
I'm surprised. Okay. And I'll grab the Sharpie. And what are we calling this?
Oh, I already wrote on here. We
Oh.
have calcium chloride. I hope that's the right formula. So we'll just
Looks
leave
like
this
it.
way.
Well, you're good, calcium
So
chloride.
what you do now is you just basically, we can set that on a nice flat surface. And you're going to pour, let's take this out so we can see it really well. And you're just going to take and pour this. Watch closely.
Oh, that is so disgusting.
Do you want to reach in there and grab that?
No, I do not.
No?
I
Well,
will.
you know, when I poured the calcium chloride solution has the, it has calcium in it, obviously, but the Gaviscon has sodium alginate in it, which is basically from kelp. And when you mix them together and pour them together, you get, everything's mixing up, and the sodium is replacing the calcium ions, and it's forming this nice gelatinous worm. And I made some earlier again today, and you can just, they're ooey gooey. Firm. Kind of looks like intestines.
It
like
really
these are,
does.
These are awesome. And the longer you leave them, the more firm they get.
Sure.
So
can I touch the one that you,
yeah.
well,
Oh,
not that
okay.
one.
Here's one from
Yep.
earlier. You can see how firm it is.
Yeah, it's like
Kind of like a worm.
like al dente spaghetti.
Oh, like spaghetti. Yeah.
That was really, really super gross. My kids would love this.
Super easy. Again, this one's super easy. Again, we pride ourselves at Praxis in being able to find the materials simply and easily to get, right? These are in the grocery store, hardware store. Super, super fun. Tons of fun.
Awesome.
Again, this would be a good holiday experiment. You could have it having the kids make, and because it looks really like intestines, I think.
Oh yeah, have the kids have some friends over and tell them all sorts of stories. Ooh, okay.
Okay, we have one final
Holy.
slime. Okay. This one is more of a sensory slime. I get questions quite often. What kind of slime could we do, for that sensory, the feeling for students that might like that. So this one works really well. This one takes a little bit of pre-planning because you do need to soak what's called chia seeds right here for about 12 hours or so. They come like this. They're just in a bag. And if you hold out your hand, you can see they're just a black seed with an outer shell. I use the black ones. You can get different. I think you can get white ones as well.
Can I
They're
poke
kind
it?
of a health food craze right now. Yeah, you can feel them. It's not going to hurt you. People eat these.
Okay.
No worries at all. Should we make this one colorful? Do we want to add some blue coloring to it?
Absolutely.
Okay, you can add it right into the chia. So basically, I just took a 1/4 cup of chia seeds, and you can see how they've grown in the last 12 hours,
wow.
and added it to a 1 3/4 cups of just basic water, and I'm going to add a few drops of blue. And you can stir that up in there. And then again, I'm going to use just a large vessel to mix this in. It makes it a lot easier. Basic cornstarch, we're going to mix it with. My hands are all greasy from the oil still, so. Now this one, it depends on how slimy you want it, but you can pour that in now.
Yeah.
And I like to start with just about 2 cups of cornstarch, but I would not go over 4 cups because it gets thirsty, for lack of a better word, and just keeps soaking it up.
Okay.
So we'll start with 2 cups.
Get expensive after a while, yeah?
It could.
Oh, I still got a kind
Oh,
of a
they're sticky. It's
globule
hard
at
to
the
get it
bottom.
out.
I'm impressed. Okay, I think we're good.
So do you want me to mix this one?
Sure, yep.
So do you want to measure the next cup? I'll start.
Okay.
And you can feel like there's these little balls. It's, and this is much less expensive. You see lots of slime experiments with styrofoam. Styrofoam balls are quite costly, and not to mention perhaps not the greatest for the environment. But this one, you can just feel these little balls of the chia seeds that have swelled up from being soaked in the water. I think I'd like 1 more cup of cornstarch.
Do you want it all at once?
Yeah. It's still a little,
There you go.
it's still a little soupy for me.
Now, is the cornstarch going to be weird with this? You remember how when we did it with the water?
Well, you'll have to wait and find out.
Okay.
I know what you're saying, where you squeeze it and it makes it.
Yeah.
The chia and that mixture is going to quite absorb it, but you can still get a little bit of the flow when you squeeze it. See, you can see.
Yeah. Okay. I was just curious.
Cornstarch behaves like that. That's kind of its property. Oh, I'm going in.
Just commit.
And depending on how dark, because you're adding it to the chia seed, your food coloring doesn't come through as much. But you don't need food coloring. But of course, children may like that. Well, adults too. Don't get me wrong.
Oh, that is a fun one.
It's almost Play-Doh-like, but you can the feel of these seeds is, it's just incredible to have that feeling and it oozing. Here, do you want?
I want to touch it.
I'll give you.
Oh, that's not what I expected at all. That's really neat.
See how it flows?
I do.
Just, you get the squeeze, you can see it turning to liquid, solid. Just like your quicksand cornstarch.
Yeah. It's actually not, I was worried that it was going to be like really sticky, but it actually seems to be coming off my hand okay.
Yeah, and depending on how, you could add more cornstarch to this if you want, but I kind of like that consistency.
Yeah, definitely. This is like true slime. Yeah, I love it.
And I'll be blue for the next couple days now, as you can see.
So maybe if you're mixing in a high concentration of food coloring.
Wear gloves, but if you're not opposed to being blue, it's not gonna, it wears off. So if you see me out later today and I'm blue,
Say hi.
this would be why, because I'm busy doing science and experimenting. So I think we've done a lot of slime experiments today.
Fantastic.
I hope that some of our fans that love slime will take these experiments and do them, try them. And as you've seen, they don't always work out. Keep experimenting and trying. That's what science is about, is learning and discovery. But I think that's all we have today. So if you want more information about Praxis, visit our website.
www.praxismh.ca.
Or give us a call. Thank you.